Okay, so in this video we're going to be looking at using orbital diagrams in order to answer some questions about the various behaviors of an atom. In this case we're going to talk first about how many unpaired electrons there are in an atom of iron, and then does that make it paramagnetic or diamagnetic. We obviously need to understand those terms first. So paramagnetic, just as a reminder, is referring to a case where an atom shows magnetic properties because its spin states of its electrons are not canceled out. So if you have any unpaired electrons, it's going to have an unbalanced spin, and therefore the magnetic fields will not cancel each other out. It will have magnetic properties. Diamagnetic refers to when all of the electrons in the atom are paired in their orbitals, and therefore with those spins paired we have no magnetic properties. Okay, so in order to do this for iron, the first thing we're going to need is the electron configuration. Okay, you can see the previous video how to do the whole one. I'm just going to write it out in the shorthand. So we have Fe, which is the noble gas shorthand, is going to be argon. That's the last noble gas we've completed. And then we're going to come along and say 4s2, and the iron has 6, so that'll be 4s2, or we start into the 3D now, so 3d 6. Okay, now looking at this, when we write out the orbital diagrams, there's a couple ways you can do it. You could just do it with a line, kind of like this, and say that's the 4s, and there should be 5, right, because a d orbital has 5 suborbitals, so this could be the 3d. Okay, so that's one way to do it. The other way is to just box it, so you could say that's the 4s, and then you draw a series of boxes for the 3d. Okay, either way it's going to be the same. You would simply label 4s 3d. Okay, I'm going to go with the boxes, just it's a little bit simpler to do at this point. So when I'm going to put these electrons in it, so I know I have 2 in the 4s. Remember, one has to be spinning up, the other pointing down, representing the opposite spin states. And that's just anytime you have 2 orbitals, because of the Pauli exclusion principle, 2 electrons in an orbital, they need to have be the opposite spin. Okay, we can't share identical all 4 quantum numbers. So if we look at the 3D, there's 6. So I'm going to put them in order. 1, 2, 3, 4, 5. Okay, originally we spaced them all out like this. They're electrons. They don't like to be jammed next to each other if they can help it, because they will repel. Hund's rule states that we need to maximize the same spin, and therefore all of these that we put in should be the same spin initially. And then we have one more to put in, a 6, so we'll put it right here, pair it with that one. That's the one that's going to be down. So now we can answer this question: how many unpaired electrons are there in an atom of Fe, and is it paramagnetic or diamagnetic? Well, we have 4 unpaired electrons, and because we have unpaired electrons, this element is therefore paramagnetic. Okay, so that's how we use orbital diagrams to answer questions about the nature of that atom and the electrons and so on and so forth. In the next case, we're going to look at a different one, and we're going to see sort of how you might deal with some exceptions.